We have, according to our agenda, the next presentation to be made by Aleksandr Egorov. He is from JSC Space Rocket Center Progress. He will speak about multi-level system of Earth operational hyperspectral monitoring. Good morning, dear colleagues. I'm going to deliver a report on multi-level system of Earth operational hyperspectral monitoring, which is implemented within the framework of an innovation development of aerospace cluster of Samara district, and through the own efforts of the company with in cooperation with GAO and MGA2. This project on multi-level system of Earth operational hyperspectral monitoring is oriented towards development of regional system of operational hyperspectral monitoring of psychochemical conditions of natural and anthropogenic objects based on data obtained with hyperspectral sensors used in space, aviation, and ground facilities in the interest of regional state authorities and local government, as well as in the interest of enterprises having different form of property to solve a wide range of socioeconomic tasks. This slide shows the actual structure of the multi-level system. Here you see 3 levels, and the 3 levels are needed. First of all, hyperspectral sensors of Earth operational monitoring allow us to get 30-meter resolution or better. Aside from the military satellites, the American one could get a 4-meter resolution and 4 bands, but the civil satellites can get a permit to have only 30-meter resolution. The aviation segment of the system is used for validation of space data and for monitoring of Earth's surface. The ground level is represented by stationary and mobile laboratories. They're needed to get different bands of objects of interest using the manual spectrum of radiometer, and now we used field spect 4, which helps us get information in a broad range of the band from 0.4 to 2 meters and to 100-251 channels. This sub-project of multi-level system of Earth operational hyperspectral monitoring consists of a number of sub-projects. First is the development and examination of plane laboratory equipped with a hyperspectral sensor, 0.4 to 2.5 micromillimeter and high precision navigation equipment. The attestation and certification of this laboratory. The second sub-project is the development of hyperspectral data fund, which consists of all the required data. This fund will be needed for processing and delivery of information to the users via web services. Next sub-project is development of system of stationary and mobile physical and chemical laboratories to study anthropogenic acids. Next sub-project is the development of software of thematic processing information obtained from the hyperspectral monitoring system. And in conclusion, for the further development of the system, we need to organize business structures for dissemination of remote sensing information, because hyperspectral information is quite a sophisticated. It is hard to integrate it. Few people know about it, and mostly people use panchromatic or multispectral images. The space segment of the system is represented by resource P satellite, which has different types of payload, and I will speak only about hyperspectral payload, which allows us to have 30-meter resolution and 50-meter breadth of swath. The navigation system is represented by the Rusachok airplane, which was developed by the Design Bureau Progress. And here I will tell you a few words that we are flying N2 plane, which is not really convenient, and we're waiting for the commercial use of this Rusachok airplane so that we could use it for our purposes. And the aviation hyperspectral equipment ISO Phoenix, which has many bands, and the main peculiarity is that it can work on the parallel in near and sphere. Ground facilities of the monitoring are represented by stationary and mobile physical and chemical laboratories. In the left part of the slide you can see the actual equipment, Hyperspectral full, and the actual workflow of getting earth and water surface sampling. Here you can see also the sampling of water and soils. Then we do the integrated chemical analysis, and this information goes to the database of hyperspectral signatures. From the spectrum radiometer, the information also goes to the database where it is correlated and assessed. A few words about this. We're developing under the ground segment the database for the signatures. Now we have about 400 spectra and information about weather conditions and additional information about chemical properties, which were acquired in the Samara region. Development of software for thematic processing of information, hyperspectral data. The first step here would be the segmentation of the object of hyperspectral information based on the correlation of spectral characteristics. Second one is identification of spectral characteristics for selection of objects, then comparison with reference spectral characteristics and classification of the object, and acquisition of thematic map. This slide, the following three slides will demonstrate the products that we can acquire by using the system. This slide shows monitoring of oil and slate collectors. In Samara district we can do classification within a class, not only identify on the image the actual oil and slate collectors, but also classify them. When we collect enough signatures on chemical properties, then we'll be able to assess the concentration of this substance in the oil collectors. Then we show how we prepare a bathymetric map using echo lots, and underneath you can see the bathymetric map built on spectral characteristics of the hyperspectral image. Next, you can see the monitoring of landfills for solid municipal waste. We can not only identify landfills, but also classify them and assess them, the level, the actual composition of those landfills. Here I have described the tasks that can be performed by hyperspectral data. That includes water quality monitoring, soil sanitary classification, assessment of contamination level, soil fertility, mineral composition evaluation, vegetation cover, agricultural and forest landscapes, and so on. Market. The market, the United States market for hyperspectral information. This slide shows the information on the assessment of the market, represented by two leading scientists in photogrammetry and remote sensing, like Charles Mandela and George Hapner. As you can see, the sustainable development of the market is quite obvious. By 2020 it will reach $229.4 million. Now there is certain deficit in hyperspectral information, about 30% deficit, so we should be pursuing this line of business. It's quite interesting. But there are a number of challenges related to processing of hyperspectral data. First main challenge is the lack of highly qualified specialists in the field of processing and analysis of hyperspectral data. Second challenge is the elimination of the influence of atmospheric conditions, atmospheric correction, and naturally the absence of domestic spectral libraries of natural and man-made objects. And I would also like to mention the problem of mixed pixel, which needs to be addressed in this system. That's it. Thank you. Thank you, Alexander, for such an interesting presentation. Would anybody have questions from the floor? Then I would like to ask one question. What I'm especially concerned about is the practical application. Do you already have some experience in that regard, or so far it is only in theory? Practical or commercial? Practical. Well, practically speaking, as I mentioned, on these slides that we showed the actual practical application of this system, partially, of course, but we're still using experimental equipment on the plane. Well, for instance, I'm interested in 3 tasks. First is the salinity level in water. Second, the moisture content in soil, and then search for drug-containing plants. So this is an important mission for the whole world to find drug-bearing plants on the territory of Afghanistan, like opium, poppy stock, and this is a test not only for Russia, because a lot of drugs come from Afghanistan, but also it is a big problem for the whole wide world. Do you have any experiments or plans, like when you collected enough spectral characteristics to identify drug-containing plants? I understand your question. We started working only this summer, so it's too early to say that we have full library of spectral signatures, but on the territory of Samara district we have identified a number of areas with wild cannabis. We collected their data, but so far we haven't put it into a library. Okay, thank you very much. Thank you.